Hello, my awesome algebra students. For those of you that are in class right now and I'm not with you, we have a lesson today about graphing absolute values. We're going to be graphing an absolute value equation using a table of values. So this equation that they have with the bars up on the top, right here, these bars, that means absolute value. An absolute value for what you've done, like in 7th grade, was really just talking about how far something is from 0. We're still going to be using that same exact idea, except now we're graphing it with x's and y's, so 2 variables on the coordinate plane. What we're going to be doing today is picking some values for x's and then figuring out what the y's are based on that absolute value that we're going to be using. So I'm going to make my table of values with an x and a y. The numbers that we're going to choose here for right now, plan on picking probably numbers like this. Sometimes we can't get all of those numbers to fit, but that's how we're going to do this. When I substitute -3 in place of this x right here, the absolute value of -3, how far it is from 0, is +3. Then when I substitute the -2 and the absolute value of -2, how far is it from 0? It's 2. Substitute -1, the absolute value of that is going to be 1. The absolute value of 0 is 0. Now, some students that are only halfway paying attention think that the next couple of numbers are going to be -1, -2, -3, because they're just thinking about opposites. And that's not what this is. I should be taking the absolute value of 1. How far is 1 from 0? 1. How far is 2 from 0? 2. How far is 3 from 0? 3. When I graph this, -3, 3, -2, 2, -1, 1, 0, 0, and then 1, 1, 2, 2, and 3, 3, we get this V shape. This is, we're going to call it the parent function. This is like the most basic thing that we can do with absolute value. Okay, so that's our absolute value graph. That's how we're doing the entire thing today. I do want to be able to find the vertex, and we call the turning point, switch colors here, this turning point right here is the vertex because it went from a negative slope to a positive slope, or it could be the other way around. But that vertex is at 0, 0 today, for this problem, I should say. Okay. Now, I want to find the absolute value of x, but then after I find the absolute value, subtract 2. So let's get our x and our y. We're going to use those same numbers. When I substitute -3 in for the absolute value of -3 is 3, but then 3 minus 2 is 1. Right? That was 3 minus 2. When I put a -2 in there, the absolute value of -2 is 2, and I'll have 2 minus 2 is going to be 0. When I put -1 in, the absolute value of -1 is going to be 1, minus 2 gives me -1. When I put 0 in, the absolute value of 0 is 0. 0 minus 2 is -2. When I put 1 in, I'm going to get 1 minus 2, which is also what we had right here, right? We should be seeing some symmetry as we're doing this. That's going to be a -1. When I put 2 in, the absolute value of 2 is 2, minus 2 is 0, and the absolute value of 3 is 3, minus 2 is 1. So the symmetry that I want you to notice is these numbers match, these numbers match, these numbers match. Right? When I graph those ordered pairs, -3, +1, -2, 0, -1, -1, and 0, -2. And then it turns again, and it's going to start coming uphill. So 1, -1, 2, 0, and 3, 1. This graph, I want you to notice, got a little off there, this graph looks just like our parent function, that first one that we did, but it dropped down 2 spaces, right, because of that subtracting 2. So this time my origin, instead of being at 0, 0, is going to be at right there, or the one ordered pair that didn't have any symmetry with another point. So that is at 0, -2. This problem's different. Instead of adding or subtracting, now we're multiplying by -2. And some people want to do the multiplying first and then make sure that they get a positive answer there. That's not what this problem says. It says do the absolute value first, and then we're going to multiply it by -2. So if I make my XY chart, I would have -3, -2, -1, 0, 1, 2, and 3. When I substitute in the absolute value of -3, remember I'm doing the absolute value part first, that's 3. So I'm going to have -2 times 3 is going to be a -6. When I substitute -2 in, I'm going to get 2 for my absolute value, but I still have the -2 out in front that's getting multiplied, so it's going to be a -4. When I put -1 in there, I get 1 for my absolute value, so -2 times 1 is going to be -2. Right? We didn't have numbers that were going in this order on our last examples. When I put a 0 in the absolute value of 0, 0 times anything, 0, right? -2 times 0. When I substitute 1 in, I get 1 for an absolute value, and I'll have -2 times 1. Again, notice that that's exactly the same as this one right here, so that's a -2. When I substitute 2 in, I get 2 times -2 is going to be -4. And when I substitute the 3 in, I would have -2, the absolute value of 3 is 3, so -6. When I graph these points, I want you to notice that this graph is going to still have the same shape, but it is going to look different. So -3, -6 is here. -2, -4 is here. -1, -2. I still have 0, 0, 1, -2, 2, -4, and 3, -6. So this one, again, straight sides, you could actually use a ruler, and I should encourage you to use a ruler, but when we graph this, we're going to get straight sides on all of our absolute value graphs. This graph, I want you to notice 2 things about it. First of all, it's not facing the same direction, right? It faces upside down compared to our normal one, our parent function, and it's skinnier than our original one, right? Tomorrow's lesson is going to talk about why that's happening, but I just want you to be able to substitute numbers in and get a graph from it today. The vertex again today is at, or on this problem, I don't know why I keep saying that, I'm sorry, is at 0, 0. That's all for the lesson today. We graphed absolute value equations. We were using a table of values. You have a worksheet to do today. Please fill in the table of values, graph those, and again, they should all look like that V shape. You shouldn't have any that are just straight lines or anything that gets like a W or an M shape, right? It should just be V's, and hopefully that'll make sense. If you need any help, let me know.